What's polarization of?
Polarization?
Yes. The magnetic field you could expect, but
I think it wouldn't be polarized because there is one-to-one correspondence between photon and graviton polarization, and this is there is equilibrium emission, so it's not unpolarized. So,
last slide.
last is
Then.
This is the X-ray background connected with apparition.
No. It is X-ray background observed by astronomers. They look at the sky and see that there is something coming, and there are different detectors. I don't know how well it is explained. There are some, I would say, tension in explanation of that. And initially, we hope to have complete explanation of this curve, but to this end we need two big magnetic fields. We know, for example, we need magnetic field at recombination of bigger than Gauss, maybe closer to few Gausses, 5, 10, something like that, and this is surely in contradiction with what we see now. In galaxies at the scale of 110 kiloparsec, magnetic field is simply few microgauss, and if we believe that it is rescaled like a scale factor squared, we come to a few Gauss, what is necessary. But the problem is that it is not correct to suggest that scaling is 1 over a squared, because magnetic field in the galaxies, we start from, for example, from a combination, and magnetic field dropped as a scale factor squared. So far so good, and at some stage it stopped dropping but started to rise because matter started to compress. And because of that there was adiabatic rise of magnetic field due to compression. So first decrease and then compress. So it was not 6 orders of magnitude, but at most 3.
Primordial gravity waves from inflation are not going to be diluted by your mechanics.
Are you going what?
Are not going to be diluted. Are not diluted by your mechanics. Because when we're talking about gravity waves from inflation, we're talking about very long gravity waves. And these long gravity waves stay there. They're not diluted. They are just frozen until more or less recombination. Okay, so this the part of gravity wave which is actually relevant stays there. That's whatever happens.
Okay, I have to think. Maybe you're right, but I need to think. I am inclined to agree with 80%.
Okay, and the question is, what is the co-moving size of your cluster of black holes?
Co-moving size, let me see. It depends upon, it is size of the horizon at the moment of the formation. I think it could be of order of something, mass inside horizon is equal to 1 solar mass when universe H was 100 MeV, about 10 to minus 2 seconds. In our case, temperature was approximately, let's say, 10 to power 10 or 10 to power 12 MeV. In this case, horizon size would be 6 orders of magnitude smaller, or maybe even more, 8 orders, so it would be not solar size, but 10 to minus 6, 10 to minus 8 of solar mass. So this is size of this thing.
I would like to ask you about primordial black hole binaries and LIGO observations, because it's these detectors, even network of detectors were in action. Probably people derived some constraints on these systems because they found
not yet.
Not yet.
As far as I know.
But it's in principle it's possible. I think.
Yeah. These binaries produce reasonable magnitude. Again, if we try hard. And another thing, it is in the proper frequency range. It's sufficient. There would be some, I would say, some bump or some explosive emission, but it is with higher frequency.